This, okay, this is chapter 11 practice quiz. All right, we're talking about how sampling changes the types of questions we've had in the past. First one, here we have a comparison of two colleges. Freshman entering University X has this distribution. University Y has this distribution. They tell us that they're going to take a sample of 100 freshmen from University X, right, and that's going to affect our standard deviation. And they want to know, first of all, what the probability is that X is greater than or equal to 1215. Now, very important to acknowledge one fact, that standard deviation is that symbol, which in this case is 90 for University X. However, when you have a sample, you're going to take that standard deviation and divide it by the square root of your sample size. So in this case, it'll be the square root of 100 freshmen, which is 90 over 10, which is 9. So for this part of the question, we have to acknowledge the fact that the distribution has changed, the average is the same, or the mu is the same, but our standard deviation is now 9. Okay, so we don't use the 90. So we would go through the z-score process. Okay, we'd say, okay, well, we have 1215 is our x that they're wondering about. We subtract the mu, divide by the new standard deviation. That will give us approximately 1.67. We do then table A, and that will give us 0.9525. Remembering, of course, it is a greater than, we have to take 1 minus 0.9525, which will give us 0.0475. So a couple key changes in this problem compared to our previous ones in other chapters. Changing the standard deviation based on sample size, and then remembering, of course, when it's greater than, we have to do 1 minus. In 1993, a 1993 survey conducted by a local paper 1 week before an election asked voters who they would vote for city attorney. The goal was to predict the outcome of the election. 37% said that they would vote for a Democratic candidate. On election day, 41% actually voted for the candidate. Okay, so this is the actual result. So 41% is not a statistic, that's the result of the election. That is the answer, the truth. So that's considered a parameter. But 37% came from the sample. Now because it came from the sample, it stops becoming a parameter and becomes a statistic. Alright, so again, the sample was the people that they asked. The statistic is the calculation they took from the sample. So parameter represents the actual results of the election, 41%. The sample is who they asked. The statistic is the calculation that they got from the sample. So B. Number 3, sodas in a can are supposed to contain 12 ounces. This particular brand has a standard deviation of 0.1 with an average of 12.1. If the contents in the population of all cans follow a normal distribution, this is what they're talking about. Average of 12.1 and 0.1 distribution. What is the probability that the mean contents of a 6-pack are less than 12 ounces? Okay, that's the question. Now, a 6-pack represents you're taking 6 cans into account. So your standard deviation, which is 0.1, is now going to be divided by your sample size, the root of your sample size. So when you take 1 divided by the square root of 6, you get 0.041. So now we're going to use this information. Sorry about that. Okay, so we will use this distribution, 12.1, with a new standard deviation. So again, we do our z-score. So our question is 12, that's our x value, minus 12.1, divided by our new standard deviation, 0.41. That will give us negative 2.44, which table A will give us 0.0073. Now this one we do not have to go 1 minus because it's less than. So it's our actual answer. Number 4, what sample size will give me the smallest standard deviation? Well, remember, when it samples, we do this. And it's a fraction. So the bigger the denominator is, the smaller the standard deviation. So the bigger an n is a sample size. So the bigger the sample size, the better. So 36 is better. Number 5, a similar question, except now they're saying a 12 pack, that's 12 samples. What's the standard deviation of the average contents? Okay, well, they tell us that it has a normal distribution, which is a mean of 12.1, standard deviation of 0.1, that's the same as before. But what happens to that when you have a sample of 12? So we will take the previous or original standard deviation, divide by root 12. Again, I'm sorry for that noise. And 1 divided by root 12 is 0.029. So this ends the how-to video for practice quiz 11.